All right. Well, I hope you had a nice weekend. There were certainly about 2 hours yesterday. The sun came out. I enjoy being out in the sun, and I was out when it was cloudy. At least it was warm, so I enjoyed that. We're going to get a lot better weather. We'll actually get up kind of warm this week, and so it's changing. It's definitely changing. Yesterday, I got to 80 in South Carolina, Columbia, South Carolina. Does anybody know being in Columbia, South Carolina? Ever heard of that place? So, all right. What are we doing in chemistry? Let's think about this. We already had our lab tests. We went over the lab test, and you actually got in groups and made a little contest, and you got some bonus points. And I think that showed up on Headmaster, didn't it? Is that on Headmaster yet? No. The bonus points are not on Headmaster? All right. At the end of the day today, I'll put them in, okay? So that means I'll upload around 5 o'clock. So I'll upload all the grades today. Anything was the test on there, but not the bonus points?
Nothing was on there.
All right, I'll check that out. I will check that out, okay? Somehow I thought I put that in there last week. All right, so that's where we're at. And then we're starting something new, chapter 8. And we're actually doing chapter 8, 9, and we may or may not do 15. I'm not sure yet. I know we're doing 8, 9 for sure. When we get done with those, we'll actually be doing, get back in the lab. We'll do 1 or 2 labs that are based on the mole concept. So anyway, what I do is I need you to, you've been doing a good job lately. It seems like you're a little bit more attentive. It seems like you're trying to stay with me. Now, everything I'm going to teach here is in your book. So I do want you to start reading chapter 8. It is true, though, that chapter 8 has a page, and then they'll do another example, they'll do another example. So you'll see many examples of what we're doing. And I agree, maybe you don't really want to read 4 or 5 pages when there's kind of the same kind of example. But if you'll pay attention in class, I could whittle that down a little bit so you don't have to pay attention to every one of them. So I think I can show you how to do it. Now, we're going to get into this probably for this next 2 chapters. It's going to be a little math based. So that's why I asked you to bring your calculators. So does everybody have a calculator today? All right, so just bring your calculators every day. Some of you, I think, some are going to grasp a hold of this and say, I even like this better because it has math in it. And sometimes you think, well, is math going to make chemistry better? I think it does sometimes. All right, so let's find out where we were. If you get your notes out, do you remember we talked about what a mole was? Is that correct? Did we do that? Okay. And what I don't remember is, let me double check here. This is probably not you. I don't think so. Okay. Dana, what's the last thing you saw? Right? What did we do? Equivalence.
Formula units.
Oh, we did that?
Yeah.
Okay. So does it look anything like that, or does it? Wait a minute. I just can't remember whether this is yours or another class's. Here it comes. Had we done? We had started equivalence, like 1 mole in about elements. Okay. Is that what you have too? Okay. Well, anyway, what I'll do is I can cover this up, and we can still cover it one at a time. Okay. Here we go. All right. You remember something like that? Is that one of the first things we did? Okay. Let's take a look at this. What we're going to do is, if I can teach you what is equal to what, and I can show you how to do it, and then we're going to go back and revisit factor label. Remember factor label? We're going back and revisit that. You should be able to do almost any of the mole problems. Got that? So that's what it's just going to be worth it. It's going to be worth it to say, if I learn how to write these equivalents, and I go back and study factor label, I should be able to get these problems right. All right, let's start with it. Ready? If you're talking about an element, and we know it's an element right there, and that means these are the only kind of atoms we know of in the universe. We don't know of any other kind of atoms in the universe except those. So the periodic table of the elements are the periodic table of the different kind of atoms that we've ever discovered. So 1 mole of any element, let's say carbon for example, equals this many atoms. Because what's the smallest piece of an element that still acts like carbon? It's an atom of carbon. So this is called Avogadro's number. Now, if you go to college campus, I even have one taped on the back of my wall. There's a lot of things online, and one of them has a picture of Avogadro. And if you go to college, you'll see this all the time on bulletin boards where they'll say, need tutoring, and it'll have the person's name, and at the bottom will have phone numbers and a little piece of paper. You rip them off. Have you ever seen anything like that? Where you tear them off? Okay. Anyway, one of them says, Avogadro, blah, 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 and need my number. And instead of a real phone number, it has 6.02 times 10 to the 23rd. Have you ever seen anything like that? Well, that's a little bit of nerd humor. And because instead of a phone number, he has Avogadro's number. Hey, you got Avogadro's number? Yeah. They don't mean his phone number. So, but the most important thing is that what do you put after Avogadro's number for an element? You put the word atom. And then the next part, this is where you use a periodic table. You go over here and find carbon, and I'm going to round it to 3 sig fig. So if I round that off, it'll be 12.0. That would be how many grams it would take to make a mole. Now, believe it or not, if I give you some pure carbon, if I give you pure carbon, black, sooty stuff, okay, and I weigh it on a balance, and it says 12.0 grams, and you could actually see a pile of 12 grams, because a paper clip's a gram, you could easily see 12 grams of carbon. You say, well, what's the big deal about that? I see a pile of black stuff. Well, one of the most important things in chemistry was to be able to find out in any compound, for example, how many atoms combined with how many atoms. But how can they do that in the chemistry world? How can I go and visit and say, I need to count you. I need to count you how many atoms there are. Number one, atoms are too small. We can't visit there and count them. It's very, very difficult, okay? And also, there's too many of them. There's too many of them. So, is there a way of counting something without actually counting them? You say, well, are you kidding me? Yes. Now, I want to show you, before I go any further with this right here, the first few pages of this chapter. Now, be honest with me. How many of you read any of chapter 8 so far? Just be honest. All right. So, if you start reading chapter 8, you'll think, hey, there's a nice little Ferrari there, and I wonder what this is about. I wonder what this chapter is about. And then you think you're going to turn the page and get some serious chemistry. And guess what they talk about? Jelly beans. Now, you might say to yourself, wait a minute, I didn't read that. Well, if you were to read it, it might make sense to you. I want you to imagine that we all own a jelly bean store. And we have the best jelly beans in the world. And people come, and they don't know about our jelly beans, but they come, and one person says, well, I don't know much about you, but I'll take 10 jelly beans. And so you're hiring somebody, let's say you're being nice and pay them $10 an hour. And they're sitting there, and they'll go, 1, 2, 3, 4, 5, 6, 9, 10. Put them in a bag, charge the customer, next customer. See that? That'd be all right, wouldn't it? What if you find out that lots of people start liking your jelly beans and they really want jelly beans? And now you got 10 people in line, and then one person says, I need 1,000 jelly beans of this kind. Well, now think about this. Would you, if you own this store, would you want that employee sitting there going 2, 3, 5, 6, 7, 8, 1,000? You're gonna pay them $10 an hour to count 1,000 jelly beans? You say, that would be dumb. That would be real dumb. So what you do one night, if we were all the owners, here's what we do. Instead of 10, I'd probably do 100. I'd take 100 random jelly beans, and I'd weigh each one of them by themselves. And some of them might be this. See this? 5.1, 5.2, 5.0. So each jelly bean might be a little bit different, a little bit. A little bit, not much. But what if I took 100 of them and I weighed 100 of them individually, and then I add those numbers up and I divide it by 100? What would I get? I might get something like that. Now, that would be called the average weight of a jelly bean. Is that correct? How many of those 100 jelly beans had that mass, 5.011? None. None of them had that. That's the average mass. You understand that? I keep looking at you. This is important. That's the average mass, because I know the jelly beans are different by a little bit. But now what could I do as a store owner, okay? Now, instead of my customers being mad because they have to wait so long to get ordered, what about this now? Ready? Grand opening. First customer. I want 1,000 jelly beans. Okay, here's what I'm gonna do. Take this and multiply it times 1,000. 1, 2, 3. That's 5,011 grams. I have a balance here. Get it? They take it. Shake, 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 shake. 5,011. I throw an extra one in there. 5,013. 5,015 grams. Thank you very much. Next customer. Now that person counted the jelly beans by not actually counting them, did they? They weighed it, didn't they? By weighing them, they could tell you. Are you with me or not? They never counted the jelly beans. But I feel very certain that they have 1,000 jelly beans in there, don't you? They're pretty close. Now, so chemists are in that same situation. Atoms are too small, and there are too many of them to count. So how can we count them? We need to know how many there are. And that's where the mole concept comes in. So now, let's go back to our thing here, right? If I were to get 12 grams of carbon jelly beans, and that's what they are. Do you know some carbons weigh 12 and some weigh 14? But the average is right up there. That decimal number there, that's the average mass of a carbon jelly bean atom, right? Now, if you were to give me 12 grams of carbon, how many atoms are in that pile? Can you put your mask up? How many atoms are in that pile? I know I haven't seen you since last week. What is it? 6.02 times 10 to the 23rd. What? And no, you can't even count that. In the rest of your lifetime, you couldn't count that number. But the mole concept tells me that's how many are there. And you know, this is going to be the hard part for you. Do you know if I took 12 grams of carbon and I were to combine it with 1 gram of hydrogen, and it all made a compound, it would tell me this. It would tell me that whatever I made there is 1 mole of carbon and 1 mole of oxygen. And guess what I have? Carbon monoxide. What if I made another compound, and I know 12 grams of this, that's this many atoms, what if it combined with 32 grams of oxygen? Up here at oxygen is 16, isn't it? You give me 16 grams of oxygen, you gave me this many oxygen atoms. You got that? What if you give me twice that number? Give me 32 grams of oxygen, then you give me 2 times that, haven't you? And if 12 grams of carbon react with 32 grams, here's 12 grams, 32 grams of that, guess what I know? I know that I made some compound that was 1 part C and 2 parts O. And that's how chemistry got started. How in the world did they ever know what a compound was? You look at it, I wonder how many parts iron and how many parts oxygen. That's how they did it. They counted the number of particles by not counting them, by weighing them. That's why the periodic table is so important. That number there, that decimal number, is the average mass of that carbon. Now, here's one. This is copper, okay? That's pure copper. Now, why is it we have to use the decimal number? Because in that lump of copper, there are some of those that have a mass of 63, and some of the isotopes that have a mass of 64, and they're kind of blended. I do know this thing. The average mass for copper is about 63.5. So if I had a bunch of jelly beans, some were 63 and some were 64, and the average came out about 63.5, I bet about half of my jelly beans are about 63, about half are 64. We have to use that number because, see right here, it costs a lot of money to separate isotopes, a lot of money. If I want to do chemistry, I'm just going to use copper. And when they survey copper around the world, that seems to be the average mass of a copper jelly bean. And that's what we have to use. Now, did I go over your head a little bit? A little bit? Stay with me a little bit. Now, let's get into the nuts and bolts here. Can you write the 3 equivalents for any element? You think you could? Maybe you just got here, okay? Well, let's try another element. Did I do uranium with you guys? Let's try it. All right, ready? You start out here, 1 mole of uranium, and don't ask me a mole. Don't say, hey, what's a mole? It's like a dozen, isn't it? If I say, what's a dozen? Do you say, I wonder if that's 12? You don't. You say, a dozen is 12, isn't it? What's a mole? A mole is that number, isn't it? It is. There's no question. I don't understand why a mole is 6. It is. You never say, I don't understand why a dozen is 12. It is, isn't it? Isn't a dozen 12? We don't question that. We just know it. And if I say a mole of uranium, how many atoms do you think I give you? This many. Period. We don't need to argue that. Now, how many grams would it take? Just if I said, how much does a dozen weigh? You'd say, a dozen what? How much does a mole weigh? What are you going to say? Come on, do it. A mole of what? A mole of carbon, 12. A mole of uranium. Oh, wait, hang on. Right there. 238 grams. Oh, those uraniums, those guys are heavy, aren't they? If I gave you a dozen cars, a dozen grains of sand, would they have anything in common? Yes, they would. Not mass. What would a dozen cars and a dozen grains of sand have in common? Say it again. A dozen. There'd be 12 of them. What's a mole of carbon and a mole of uranium have in common? Not mass. The number of particles. As I keep looking at your eyes, okay? Your eyes are the only thing that can tell me what's going on. I can't see, May, I can't see you, so I need to, if you don't mind, move over or something, because I need to be able to see your head. Now, you're okay on this one? If you don't have that in your nose, go ahead and put it in there. Let's try another one. How about sodium? Can you do this right now? Can you actually take any element on the periodic table and write out their 3 equivalents? All right, try sodium. Try sodium. Ready? 1 mole sodium equals. I'll bet it's going to be this many. And what goes after Avogadro's number?
Attention students, please pardon the interruption for a quick sports announcement. Dialectic baseball practice is canceled. Track practice has been canceled. Tennis practice has been canceled. Varsity girls soccer will meet in the gym from 3:30 to 4:15. Dialectic girls soccer practice will meet in the gym from 4:15 until 5. And varsity baseball will be in the batting cages from 3:30 to 4:30. Thank you.
Okay. So, 1 mole of sodium equals that many atoms of sodium. And how do I finish the statement? How do I finish it? I've got moles, atoms. I'm going to have grams, aren't I? Let me see. May, can you help me out? How many grams would it take to make a mole for sodium? Yes. Very, very good. All right, is everybody okay? Now, you said we actually went past this last week, right? What happens if we were to go into not elements but compounds? And there are 2 kinds of compounds you're supposed to know about. One of them is when nonmetals form compounds with nonmetals. Remember those? We even named them different, like carbon dioxide. Remember that? Sulfur, trifluoride. All right. Wait. So here's what you do. Watch. Very similar. 1 mole of water. Is this a non-metal? Okay, so water, that's a covalent compound, isn't it? 1 mole of water is still that many pieces of water, but you can't put atoms after that. Why not? And again, if I lose you here, you won't be able to do any of these. Why do I not put atoms after here? Say it again.
It's not an element.
Yeah, there's no such thing as an atom of water. What? Is it on the periodic table? No, then it can't be an atom. Oh, but I thought there were atoms of water. No. Are there atoms of air? No. Plastic? No. Skin? No. If it's not on there, there's no such thing as an atom of it. So what's the smallest piece of water that acts like water? And here's what it looks like if I were to draw it. What do you call that? What do you call that in 9th grade? Molecule. So what did I put after Avogadro's number? I put molecules. It's really the same idea, isn't it? And now, let's do the last part. How am I going to do the last part? Look on the periodic table. How many hydrogens do you have? How many hydrogens do you have here? 2. How much is each hydrogen? How much is each hydrogen? If you have a periodic table right next to you, this makes it a lot easier. If you have your book, if you have a periodic table with you, it makes it a whole lot easier. But each hydrogen weighs how much? A mole of hydrogen weighs, what is that, 1.0 what? 1.07, something like that? Okay. Now, so each hydrogen weighs 1. So it's like 1, and another mole of hydrogen would be 1, and then a mole of oxygen would be 16. And there's 16 right there. 15.999. I'm going to round up to 3 sig figs. That's going to come out to be 16.0. So a mole of water would be 18 grams of water. 18 grams of water. Now, because I'm going to have vocabulary on the next test, I don't want you to learn it because it's on the test. But a word I'm going to use all the time is molar mass. Now, I'll bet you could figure out the molar mass. The molar mass of carbon is 12 grams. The molar mass for uranium is that. Do you think you could figure out the definition and what molar mass means? Julie, what do you think? If I ask you to tell me what is molar mass just by looking at these numbers, what do you think they mean?
Is it like kind of how much they weigh?
How much? What now?
Like
How many grams? How much? How much? It's how many grams what? 1 mole. What is the molar mass? It's how many grams it takes to make 1 mole. How many grams of carbon does it take to make 1 mole? 12. How many grams of water does it take to make a mole? 18. All right, try another one. You try one. Carbon dioxide. 1 mole. Did we do this already? Carbon dioxide? Yes? All right. 1 mole of carbon dioxide equals 6.02 times 10 to the 23rd. What am I going to put after that? Don't put atoms. Is this a compound? It's a covalent compound, right? So we're going to put molecules. Now, what about this last part? Aurora, can you help me on this one? How many grams? What's the molar mass? How many grams of carbon dioxide would you need to make a mole? Now see, if you're looking on the periodic table right now, you're doing the right thing.
So,
How many carbons do you have?
1, so it's,
And each carbon weighs 12. Okay, that's 12.
and then 2 of 16.
And 15.99, if you round off 15.99, that's 16, isn't it? So you got an oxygen, that's 16. But how many oxygens do you have? So you got to put another one, don't you? All right, so how many grams of CO2 would be a mole?
44.
Yes, yes, yes. Excellent, excellent. You got it? See, if I can teach you to write these equivalents and I can show you factor label, you'll be able to do anything. You'll be able to do anything. All right, you okay with CO2? We do this before? Okay. All right, did we do a special case? Here's a special case. How about O2? A diatomic, Now, this is kind of neat because even though it's called a diatomic element, what is O2 made of? What is O2 made of? 2 oxygen atoms. And it's a nonmetal bonded to a nonmetal, so it'd be a molecule, wouldn't it? The stuff I breathe, even though it's called a diatomic element, is a molecule of O2, isn't it? All right, so let's try that one. 1 mole of O2 is 6.02 times 10 to the 23rd molecules of O2 equals, and 16 plus 16 is 32. And the last thing, and this is where the bell was ringing, I think, there's one more thing we have to know. What if it's a compound and it's made of ions? Meaning it's usually a metal positive ion and a non-metal negative ion. You get that? What are you going to put after Avogadro's number there? And I didn't make up the name. I don't necessarily like the name, but it's one of those. It's a unit. It's an ionic unit. I would have called them ionic units. They decided to call them formula units. All right, everybody got that? I can't change that. I don't like it because it takes a long time to write formula units, and I don't like to use the abbreviation for formula units. And some of you will giggle, and some of you won't, and some of you aren't paying attention. That's all right. But I probably won't use the abbreviation for formula units. Will you? Yes, as a teenager, you'll say, oh, wait, if I abbreviate, okay. And so probably some of you will. All right, so here we go. 1 mole of sodium chloride, and that's a metal and a non-metal, isn't it? So it's an ionic compound, equals 6.02 times 10 to the 23rd formula units of sodium chloride. And how do we get that? Now be careful. When I say round to 3 sig figs, 35.45, that rounds to 35.5. So I use 35.5 for chlorine and 23 for sodium. That's how I got 58.5 grams of sodium. All right. Are you ready for the hardest question I've asked you in 3 days? How about that? All right, let's try this. Give me the mole equivalents for this guy. There you go. If you can do this one, I'm gonna yell hallelujah or something. All right, you try to get the other 2 parts of this, and if you want to talk to anybody, if you're sitting next to somebody and you said, "Hey, I want to talk to somebody about this," we didn't do this one, did we? Okay, good. This one you have to think. Is this an ionic compound? Is this an ionic compound? Is this a metal plus part of the compound? This isn't a polyatomic ion, isn't that a negative part? This is an ionic compound. Now you can talk to somebody, but man, if you can get this one right, you have something going on. Like I said, if you want to try it by yourself, you said, I'm going to try this by myself. And then if you're not sure, you can talk to your neighbor and say, hey, what'd you get? I'll bet all of you put this number here. 6.02 times 10 to the 23rd formula units of BaNO3. I'll bet you got that far, didn't you? All right, if you're finished, find somebody else who's finished and compare your answers. What's the molar mass for barium nitrate? How many grams of barium nitrate would it take to be a mole? And if you're not looking at the periodic table, you don't know what you're doing. All right. Leda, did you agree, or do you have a different number than she has?
We're still working.
Okay.
Used on the nitrate.
On the what?
The nitrate.
Okay. And that's why I gave you a hard one, okay? I gave you a hard one, so you had to think about it. Do you guys agree? Hey, back there, Leila, if you guys disagree, how do you know maybe one of you got right or maybe both of you got wrong? How do you know?
We didn't really disagree. We're been.
Oh, you both got the same answer?
No.
Oh, you just weren't sure how to do it. All right, Delaney, you weren't here, but if you turn around after you get it done, ask May what she got. Are you getting the same number? Okay. All right, Daniel, what about you guys? Are you matching?
He's still working on it.
Okay. This will be interesting to see what kind of numbers you come up with.
I don't think mine's right.
Now again, this is about the hardest one I can give you. This is about the hardest one I can give you to find the molar mass of. So if you eventually figure out how to do this one, the rest is a piece of cake. All right. Is anybody matching anybody else? Okay. All right, well, that's good. You know what? Again, this is the hardest one I could give you, right? Here, I'll give you a clue. I'll give you a clue, okay? Watch now. How many bariums are in this compound? 1 barium. All right, let's go over here. Let's go find him. And what does that say? 137.3? All right, in the calculator, I'll put 137.3. Now, this is the tough part. How many nitrogens are in there? Look at this right here. How many? Careful. I'll give you a clue. I'm going to draw this for you. Here's my barium ion. Here's my nitrate. NO3. NO3. Oh. Now, isn't that right? Look. Isn't that right? This guy right here is -1. This guy right here is -1. Do you see it or not? So how many nitrogens are there? Watch my hands. 2 times 1. Oh. Okay, try it again. I drew it for you. Here's my barium ion, and here's a nitrate ion. Nitrate is NO3. And I got 2 of them, don't I? So I have 1 barium. Check. How many nitrogens? Watch. 2 times 1 is what? Oh, that's the easy question. All right, each nitrogen is how much? 14. And I have 2 of them, right? So I have a calculator. I put 137.3. Then what's 2 times 14? Okay, we're going to add that. Now, how many oxygens do we have? Watch. If you want to draw these out, you can and say 1, 2, 3, 4, 5, 6. Or you can do this. What's 2 times 3? 6. 6 oxygens. Isn't that right? 2 times 3? All right, how much is each oxygen? Isn't it 16? All right, here's what I would do. I would add 137.3 to 28 to 96. All right, everybody do that and tell me what you get. And again, this is about the hardest one I could give you. And let me look, and drum roll. Did everybody get around 261.3?
Me and Layla did.
You did?
Yes.
You both got it. Independent.
I was the one that said it was 6 oxygen, but she wasn't listening. But then we did it.
Okay. Anybody else get 261 the first time? You did it? Excellent. Now, what about now? Could everybody do it now, you think? Okay, let's try it again then. Let's go again. Ready? Look at this right here, May. Look at this right here. See this guy right here called barium nitrate? Now.
You have to yell hallelujah.
Oh. Hallelujah! Oh. Well, anyway, let's look at here, May, and everybody. This compound has 1 barium in it, and that's why I put 1 barium. And I look over here, and how much does 1 barium weigh?
1 barium is 56.
No, I think it's 137.3.
Where did it say that?
Do you have a periodic table with you?
It's possible.
I find barium, and I look at this decimal number. See that decimal number?
Oh, yeah.
And I round that to 3 sig figs. And in this case, I guess I had 4 sig figs, didn't I? So 137 or 137.3, either one. I'll take either one.
Okay.
Now we go over here. Nitrate is NO3, and I have 2 nitrates. See that? So what's 2 times 1 nitrogen? Does everybody know what nitrate is? 1 N and 3 O's? Does everybody know that's 1 N and 3 O's? And if I have 2 of them, that'd be 2 N's and 6 O's, wouldn't it? Okay, so I need 2 nitrogens. And I go over here, and each nitrogen weighs 14. And I have how many nitrogens? 2. 2 times 14. That's 28. And then how many oxygens do I have? Look here. 6. And each oxygen is how much?
16.
Round up to 3 sig figs, you get 16.0, right? 6 times 16 is 96. So I add this to this to this, and I get 261 or 261.3. I'm okay with that. Either one of those. Either one of those. What do you think? All right. Now, what I like to show you something now. We haven't done factor label for a little bit, but I want you to keep this sheet with you, okay? Keep this sheet with you. I'm going to show you I'm going to review factor label. All right. Hey, by the way, Daniel reminded me, and you should remind me also, the lab write-up was due the day you took the lab test. I'm not going to count late, but you should turn this in. So that I need that today, because it's my fault for not reminding you, but it was always due the day you took the test. So anyway, go find that. And I have a stapler. I don't know. Well, remember I gave you this sheet, and it told you exactly what to do, and it had the title, it had your name and period, and had the date, and it had your objectives, and then it said procedure. Remember those? And then most of the observations are there. I mean, they're there. And then you had another section called analysis of results. You had to answer some questions. Remember that? And then there was another section called follow-up questions. Remember that? Okay, and that's what. See, I should see a balanced equation for each reaction. And then I thought there was one. Was there one called conclusion? What's the other section called? Wasn't there another one called follow? Oh, that's follow-up questions. Yeah. Oh, there you go. Here you go. Follow-up questions. He's got that, and then he also has another section called conclusion. Right. As far as I know, everything looks really good. I could probably grade this in 1 minute. I could probably go through this again, and I'll bet I could grade this in 1 minute. So well done. And that's the order they were supposed to be in, isn't it? Remember the paper I gave you? Told you what order everything is in? If you lost that paper, I always have one posted on that back wall back there, right where the door is. But I'll tell you what I do. I can't grade these today anyway, so if I get them by tomorrow, if you can give me to today if you want. If you want to staple them right now, there's a stapler right over there. If you want to staple them and hand it to me, I'll take them today. But I like to do a little bit of factor labeling before we leave today, right? All right. So let's start, and I'm just going to make up a problem, and we're going to see how well you do. All right. What if I had 1,000 grams of, let's do sodium. And I said 1,000 grams of sodium would equal how many moles of sodium? All right. Now, since we haven't done factor label since probably the second quarter, let me go over how to do factor label, okay? Factor label is so powerful, it's going to make you look smart. You get it? It's going to make you look really smart. You say, well, I already am. Okay. Hallelujah. Okay. But anyway, it's going to make you look even smarter. How about that? What's step 1 in factor label? Do you remember that? What do you write down?
Given.
The given. And the given is 1,000 grams of sodium. It's not 1,000. It's not 1,000 grams. It's 1,000 grams of sodium. Make sure you have the whole label there. Now, this is an enumerator. This is an enumerator. That's an enumerator. So I just want to remind you that all those are things that are in the numerator, aren't they? Doesn't your math teacher say things like this? Well, everybody knows 3 is 3 over 1. You ever say that to you? 3 is the same as 3 over 1. Well, guess what 1,000 grams of sodium is? 1,000 grams of sodium over 1. Now, what's step 2? To multiply the given times a what? What's CF stand for? A conversion factor. Now, I know you don't remember everything, okay? Where do you get the numbers that go into a conversion factor? What it? Yes. 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 Okay, now, what I'd like you to do, before we do this problem, I'm going to write the 3 equivalents out again. And you know, the more times you do this, you're going to get to the point where you don't need a sheet. Tell me everything you know about sodium. 1 mole of sodium. Ready? Wait, look in the periodic table. 1 mole of sodium equals what? Remember this? What did I put next? I have moles. I have atoms. What's next? And maybe this will remind you. Mag. Moles. Atoms, what? Grams. Okay, now how many grams? Everybody in this room should be able to tell me. How many grams of sodium does it take to make a mole?
23.
Look on the periodic table.
23.
Everybody with me? Now, isn't that the same thing we wrote over here? Okay, now, these are my equivalents. That's a fancy name for saying something that equals something else. You get it? Did you know I had some of my honor students, and you guys can compete with them. But watch, I had some honor students that knew that this equaled that, and they knew that this equaled that. You know what some of them told me? They didn't realize that this equaled that. Oh, what? If this equals that and that equals that, then wouldn't this equal that? Isn't that right? What's your math teacher say? If A equals B and B equals C, then A equals C. Is that what they'd say? Something like that? Everybody knows that, right? So guess what? Does this equal that? Yes. Does this equal that? Yes. Do you equal that? Yeah. So now I go up here, and this is the easiest part of factor label, but some people make it hard. Look right here. Look at my original problem. What label has to go away to convert it to this? What label has to go away? Now, how do you get rid of grams of sodium in the numerator? Don't you remember that? I always remember that. I always like that in math when things would cancel, you know, like, you ever do that? I love canceling. You're 4, here 4. Yeah. Everybody likes to cancel, don't they? All right, now, so I know grams of sodium goes down there, and what do I want to replace it with? Moles. Moles of sodium. Now, stop right here because I don't understand why people do this, but let me say, how do I put the right numbers here? Watch. I look for grams of sodium down here. Do you say grams of sodium? No. No. Yes. Now, I keep my hand right there. What number has to go with grams of sodium? What number? Michael Jordan, right? 23. There's no way you should put any other number besides 23 next to grams of sodium. Look. Isn't that right? And 22 grams of sodium equals how many moles? Let's try it. Do you say moles? No. Yes. What number is going to go with moles? Every year I have people who said, oh, I want to put 6.02 times 10 to the 23rd. Why? Why'd you do that? I don't have atoms here, do I? Don't do it. Now, I just pick up the calculator. I'm ready to go. You know why? Because the only label left is the one I want. That's how I write equals. And there is no way I should miss this problem. Calculator ready. 1,000. And what are you going to do with the 23? Any number in the denominator, what are you going to do with it? Divide. Okay. So we're going to go 1,000 divided by 23. Let's do it. Do you already have it? You're ahead of me? All right. What do you got, Kyle? And we'll do three sig figs, 23.47. I'll just go to 23.5, okay? Now guess what? You just did a mole problem. They even do these in college. You can do it. Are you okay with this? One more time. Here's my given. I want to get rid of grams of sodium. I'm going to replace it with moles of sodium. And where do I get these numbers? From equivalence, don't I? By the way, I don't multiply or divide by a 1 because that doesn't make any difference, doesn't it? Multiplying by 1, dividing by 1 doesn't make any difference. Yes? All right. If everybody in this room gets this right, I'll say hallelujah again, and I'll give away $1 to somebody. I can't give away to everybody. Can't give away to everybody. All right. All right, let's do another one. Ready? Let's do another one. Yes. What happened?
Oh, it's 43.5.
What happened?
The answer is 43.5.
Oh, I thought you said 23. You said 43? Did everybody get 43.5? Okay, that's my fault. I didn't hear you correctly. Thank you. All right, here we go. Here's a hard one. By the time we do about 4 or 5 of these, you're going to be really good at it. 1 million water molecules equals how many moles of water? Now, I'm going to give you a little hint. Okay, let's go ahead and get the problem started. What are you going to put instead of the number 1 million? Well, you know from way, way back in the first semester. Say it again.
10 to the 6.
Yes. Now, I know that's my given, and then, that's my given, and I'm going to multiply it by a conversion factor, aren't I? Okay, ready? What label has to go away? I want to change molecules into moles, right? What label has to go away? Now, it's molecules of water, right? And what do you want to replace it with? Moles of water. Now, before I do the problem, I'm going to write out my 3 equivalents. Okay. Now, even though we did it on this paper, can you try it again without looking at the paper? Let's see. 1 mole of water. Help me out here. 1 mole of water equals what? 6.02. Help me out. 6.02 times 10 to the... If you can't write these equivalents, we're in trouble. Okay? We're in trouble if you can't write the equivalents. 1 mole of water equals 6.02 times 10 to the 23rd. What? What's the smallest piece of water? Molecules. Now, how many grams? What's the molar mass? What's the molar mass of water? Say, well, let's see. Each hydrogen's 1. I have how many of them? I have 2 H's. 2 times 1 is 2. So 1 plus 1 plus what? 16. 18 grams of water. Now I can do the problem. Let's go back up here. This is your conversion factor, right? All right, what number goes here? Do you say molecules of water? No. Did you say molecules of water? No. No, you did. You did. Then I'll put that number right next to that. 6.02 times 10 to the 23rd. And now I need moles of water. Do you say moles? No. No. Yes. What number goes next to moles? 1. Now, I know that I'm going to get the right answer as long as I know a little bit about math. A little bit. Do you know why I don't want you to miss this problem, but you're going to miss it because you forgot something that I taught you and something your math teacher taught you. You know what's gonna happen if you just say, 1 times 10 to the 6th divided by 6.02 times 10 to the 23rd? You know what you're gonna do? You're gonna miss the answer by a little bit. Like 46 powers of 10. That's a joke. 46 powers of 10 is not a little bit. Now, you know why you're going to miss it? Because you wanted the calculator to divide by 6.02 times 10 to the 23rd. But if you didn't put in parentheses, if you don't put in parentheses, here's what the calculator thinks you said to it. Divided by 6.02. And the calculator says, okay. But guess what happens when you put times? He thinks you're writing a numerator again. And he puts the 23 up there. So here's how you do it. Ready? Ready. 1 times 10 to the 6th. If it's a numerator, scientific numbers, numerator, don't worry about it. Scientific numbers, denominator, put parentheses around it. Get it? Put 1 times 10 to the 6th divided by parentheses. Divided by parentheses. Ready? 6.02 times 10 to the 23rd. Put the other parentheses. Does your calculator make you toggle over after you get to 23? Does it make you do a space? Okay, then you put a parentheses and then say enter. And you know what? Then you'll get the right answer. All right, look at your neighbor. Look at your neighbor and see if you get this right. Show them on your calculator what you got. And by the way, what does E mean? What does E mean? Times 10 to the. Okay, don't forget that E. That's important. Did you match? Was she 46 powers of 10 different than you? Oh, you're still working on it? All right, one more time. You'd say 1 times 10 to the 6th, and then say divided by, parentheses, 6.02 times 10 to the 23rd, parentheses, enter. Oh, I gotta stop here. Hey, could everybody check to see if I got it? I just made this problem up, so I don't know what the answer is. Daniel, what you got?
I got 1.66 times 10 to the
Negative 18. Is that what everybody else is getting? Okay, hey, very, very well done today. Very well done today, all right?